Hi algebra students, grab your 10-7 graphing linear inequalities notes template and let's get started. We're going to start with a warm-up. I want you to try this by pausing the video and completing these problems. There is a typo on the second warm-up question. Instead of f of -1 and g of -1 and f of 2, these should all read g's. So make sure you fix that before you start plugging in. So you'll see that I replaced x with -7 for the first plug-in on the first warm-up question. To get 51 over -10, you could also reduce to about or equal to -5.1. G of 0 is -2/3, and G of 5 is 27/2. When they ask for the range, we're going to put that in set braces with a capital R or the word range to represent the range of the function. For the second warm-up question, just make sure that you made that correction. It should be G of -1, G of 0, and G of 2. G of -1 is -12, G of 0 is 12, and G of 2 is 12/5. We recommend for this unit and this section in particular that you have colored pencils or highlighters or something with different colored inks that you can use in your notes because it'll make it visually easier to interpret your graphs. There's some bullet points we want to go over before we begin. How do we solve inequalities? You'll remember we just finished up the inequalities unit before Thanksgiving break, which was chapter 10. We solve this just like we would in an equation. So the first fill in the blank we're looking for is equation. What happens when you multiply or divide by a negative with inequalities? It flips the inequality symbol. So the inequality symbol when we go to graph an inequality like we will for example 1, the first thing we want to do is get it in slope-intercept form, get the y alone. So we're going to follow the same kind of steps that you just finished up on your chapter 8 test when we ask for slope-intercept form. I'm going to just rewrite the problem underneath 3x minus 2y, but I'm going to make that plus -2y greater than or equal to -4. The first thing I need to do is I need to move the x term. So I'm going to subtract or add -3x to both sides. And when I do that, I'm left with -2y on the left, greater than or equal to -3x plus -4. I'm going to put the x term in front of the constant. And then the last step is I'm going to divide by the coefficient in front of the y, and it's a -2, so I should be automatically thinking, well, this inequality symbol is now a less than or equal to. I've got y alone on the left side, which is what I want. A -3x over a -2 becomes a positive 3/2 slope, and we're going to reduce -4 divided by -2 to be positive 2. Now, there are two things that you need to remember. When we did the circles over the number line graphs for inequalities, we did less than and greater than symbols as an open circle. And now they're going to be dotted lines. So in the first fill in the blank, you're going to put a less than and a greater than. When we did inequality graphs over a number line, when it had the or equal to, it was a solid colored in circle. That means that those are going to be solid lines. So we're going to have less than or equal to and greater than or equal to being solid lines on the graph. We're going to shade it. It's going to be shaded on either side of the line. If it is a less than or equal to, once you solve it, once you get y alone on the left side, then you're going to shade underneath it. And I'll show you how to do a test point just to make sure you can feel confident about your answer. And then the last one is to check it with the test point. So we're going to graph it from our slope-intercept form. So I'm going to look at this in order to graph. The first thing I'm going to do, just like with an equation, I'm going to graph the y-intercept. So I'm going to go to the y-intercept and go up 2 and make a dot. And then using the slope, I'm going to go up 3 more and to the right 2 to make my next dot. So 1, 2, 3, to the right 2. So right above there. Now you can also do the reverse. You can go down 3 and to the left 2, and that will find you another ordered pair on that same inequality line. And then I'm actually going to keep going and making points along the line so that it's easier for me to draw a straight line. So I'm going to go up 3 to the right 2. And then because this is a less than or equal to, it's going to be a solid line, and we're going to connect those points, making sure that we still have some air. Oh, that's a very thick line. Let me do that a little bit thinner. So we're going to connect those points with a line and making sure that we have arrows in both directions. Now, in order to shade this, what we're going to do is we're going to plug in a test point. And as long as the line does not go through the origin, that's the test point that we want to use. So I'm going to use 0, 0, and I'm going to go back to my original equation, and I'm going to plug it in. So if I'm going to make a note, I'm going to plug 0, 0 in. My original equation would be 3 times 0 minus 2 times 0 greater than or equal to negative 4. On the left side, we just get 0 greater than or equal to negative 4. That is true. 0 is greater than or equal to negative 4. So what we're going to do is you shade where it's true, just like you did on the number line graphs. So what you're going to do is you're going to go to your graph and you're going to shade where the 0, 0 is on your graph, and it's below the line. And we could have predicted that as well, because when we looked at the inequality when we solved it for y alone, we had a less than or equal to sign, so that means we're going to shade underneath. Because 0, 0 gave us a true, and that's in the shaded region, right about there. So take a look at the next example. I want you to put that in slope-intercept form, getting the y alone. So to do that, you need to move your x term by subtracting 3x from both sides. That's going to give me y greater than negative 3x plus 3. So that line is a greater than symbol, so it should be a dotted line. We're going to start at the y-intercept of 3. And the slope is negative 3, so we're going to go down 3 to the right 1, or to the left 1, pardon me, to the right 1. And then just keep going down 3 to the right 1, and then you're going to draw a dotted line through those points, something like that. And we're going to plug in a test point, and again, because this didn't go through the origin, let's just use 0, 0 as our test point. Back into the original, 3 times 0 plus 0 greater than 3. That gives me 0 is greater than 3. That is false. So what that means is I'm going to shade on the other side of the line. So my shading will be away from 0, 0 or to the right of that line. And this should actually be a dotted line. That's my fault. So I need to go back and erase. There should be some dots here because it is a greater than symbol and not greater than or equal to. The next inequality is pretty easy to graph. The only thing you need to remember is when it is just a y equals, that should be a horizontal line going through 2 on the y-axis. And it should be a dotted line because it is just a less than symbol. So there's my dotted line. And then for the shading, I'm going to plug in 0, 0. It's a less than, so it should also be underneath. If I plug in 0, 0, I only have y, so 0 is less than 2. That is true, which means I'm going to shade towards 0, 0, or underneath that line. So for the next graph, x is greater than or equal to -2. You're going to go to the x-axis and make a dot at -2. This is going to be a vertical line, and it is going to be a solid line because it is or equal to. And if I plug in 0, 0, I'm going to get 0 is greater than or equal to -2. That is true. So that means that I am going to be shading towards 0, 0 on the right-hand side. And just remember that with inequality graphs, the shading represents all the different solutions. So anything in that shaded region should give you a true if you plug it in. So let's say you were looking at the ordered pair 8, 2. Since that is in the shaded region, it's right about here, that would give you a true if you plug it into your inequality. Anything over on the other side that's not shaded should be false. So it is not a solution if it's not in the shaded region. The last skill we want you to have is to be able to look at a given graph and be able to determine what the inequality is of the graph. It's kind of hard to see it from the photocopy. It shows up a little bit better on your notes, but over here this is shaded on the original graph. So the first thing you want to talk about is you want to look at, I actually start with the y-intercept, so the second question in. Where does it cross the y-axis? It crosses right about here. Let me make that a bigger point. It crosses right about here, and that is a y-intercept of 1. So we're going to answer that question as 1. Then you're going to look at the 2 points that I gave you on the line, and you're going to just count rise over run. You could also use your slope formula to find the slope between those 2 points on the line. It might be a little confusing. We did make the origin a little bit darker, but the line does not go through the origin here. So then the next thing you want to do is count the rise over the run. So we counted down 5 to the right 5. So that would reduce to a -1 slope. Then you want to say, where is it shaded? It's shaded below. So that should tell you it should either be a less than or a less than or equal to. And I added the last question because that's important. Whether the line is dotted or shaded helps you determine which inequality symbol to use. So this is a dotted line, so we should be using a less than symbol. So going to the graph, what you want to do is throw all those pieces together. We've got y less than -1x plus 1. And then the last thing you want to do is you want to pick a test point to plug in and make sure that it gives you a true if you pick something in the shaded region. Now 0, 0 is in the shaded region, so I'm going to use that. If I plug in 0, 0 to my original inequality, I'm going to get 0 is less than -1 times 0 plus 1, or 0 is less than 1, which is true. And because it's true, I know that it should be in the shaded region, which it is. Make sure you bring any questions to your math teacher the following instruction day, and make sure that you are finishing all of the PowerPoint questions if they are not finished in class.